Today we want to continue chapter 7, Energy, Work and Power. Today we will talk about the second part of the lesson, which is work. We finished energy. We talked about mechanical energy, kinetic energy, potential energy. We said mechanical energy is the sum of kinetic and potential energy. And energy, it means it's the ability to do work. Okay, so energy is the ability to do work. What does it mean, work? Work, when do we have work? When we apply a force on an object and the object moves. That's it. So what do we need for work? Force and displacement. Force and displacement. So a force displaces an object and changes the object's total energy. Okay, so when you change an object, you are changing the total, moving an object, you are changing the total energy. How? For example, there is a book at rest on a table. When you push this book, what happens? At the beginning, while the book is on the desk, on the table, the book has potential energy because the book is at rest, it's not moving, and zero kinetic energy. Okay, when you start pushing the book, what happens? Energy transformation. Energy changes from gravitational potential energy or potential energy to kinetic energy because the book starts to move. Clear? This is the meaning of work changes the object's total energy. Work is the process of applying a force through a distance to change the energy of an object. Sometimes we have positive work, sometimes negative work. It depends on what. Positive work is associated with an increase in the speed of an object. Negative work is associated with a decrease in speed. How? Let me give you an example. For example, you are pushing the shopping cart. Okay, the shopping cart, you are pushing it, you are applying a force. And while you are pushing it, what happens to the shopping cart? The speed of it increasing. Okay, so there is a force and there is displacement. So you are applying a work. Now this, you are doing work. This work, it is what? Positive. Why? Because you are increasing the speed of the shopping cart. So your work is positive. At the same moment, what do we have? Force of friction on the wheels of the shopping cart. Now, force of friction is opposite to the direction of motion of the shopping cart. Okay? In this case, the force of friction also it's doing work on the shopping cart, but this work is negative work because the force of friction is trying to stop the shopping cart or slowing down the speed. Is it clear to me when do we have positive or negative? This is one example. We have so many examples. Good. Now, work is the product of average force applied to an object and the component of displacement parallel to the average force. Very important note. While you are pushing the shopping cart is moving forward and you are applying a force forward. So both the displacement and force, they are parallel to each other. So in this case, we have work. But look here at this example. You are walking and holding a suitcase. While you are walking now, you are applying a force on the suitcase by your hand. Okay? Now the force is what? Toward up from your hand. And you are walking the distance. Now the bag is moving how? Is it moving up and down? No, it's moving forward. So in this case, you know that you are not doing any work on the suitcase. Yes, there is no work. Why? Because the suitcase is moving forward and you are applying a force upward. So the force and displacement, they are perpendicular. They are not parallel. In this case, no work on the suitcase. Look at this example. Electric generated or lifting an object toward up. Direction of motion upward. The displacement also upward. So in this case, they are parallel. So there is work. Is it clear? So if you have force and displacement opposite to each perpendicular to each other, in this case we don't have work, only parallel, or if the force is applied with an angle. For example, the example of the shopping cart. Now, while you are pushing the shopping cart, if you look at your hand, you will see that you are applying a force with an angle. It's not exactly horizontal. Okay, maybe sometimes you are going to push it horizontal, but most of the time the handle is lower than your hand. So while you are pushing, you feel that your hand is making an angle with the handle of the shopping cart. So in this case, you remember when we have a force with an angle, what do? We resolve the force into two components, one on the y-axis, one on the x-axis. When you resolve into two components, you are going to take only a force that is parallel to the direction of motion. Okay? If there is no displacement, there is no work. Both force and displacement are vectors, and vectors at angles can be split into component vectors. The most important aspect of solving for work is remembering to use parallel force and displacement vectors. Okay? So if the force with an angle, I will take the one that is parallel to the displacement. If the displacement is with an angle, I will take the one that is after I resolve, I will take the one that is parallel to the force. Clear? Forces do work only when they are parallel to the displacement of the object. Forces perpendicular to the displacement result in no work. Remember this note, don't forget it. That force, if the force and displacement they are perpendicular to each other, in this case, what we don't have any work. Work equals 0. Here we have 4 questions. I want you to solve them all. I will solve with you now question 2 to see how do we solve work questions. Let's read the question. A weightlifter lifts a set of weights a vertical distance 2 meter. Vertical distance 2 meter. If a constant net force of 350 Newton is exerted on the weights, what is the net work done on the weights? You have to read the question carefully. Here is the displacement or distance here, and here is the force. They didn't say that they are perpendicular to each other, so it means they are in the same direction. We don't have an angle, so good. Just we apply, we write the formula, and we substitute. Okay? So the formula, as we said, work equals force times distance. We multiply the two magnitudes. The answer is 700 joules. Girls, here the work formula, force, it has to be in Newton, and distance, it has to be in meter. Okay? Distance, it has to be in meter. Let's talk about work of gravity. The work of gravity is associated with the force of gravity. Objects must move vertically in order for gravity to do work. So, we have something we call work of gravity. When do we have it? We have it when objects they are moving vertically, up and down. Why? Think with me, why? We have just said that when do we have work? When the force and displacement they are parallel. So the force of gravity is always vertical. So we need a displacement or motion parallel to it. So that's why objects they are moving toward up or down. In this case, we have on them work of gravity done by the force of gravity. So here you are lifting an object toward up. So what happens in this case? There is a distance, you moved an object a distance, you change the height of the object, and at the same time there is force of gravity, which is what? What's the name of the force of gravity? The weight of the object. Okay, always the weight of the object is the force of gravity on that object. So the formula for work here is the same. Work equals force of gravity times displacement, which is parallel to the force. Force of gravity, we said it is weight. So mass times g. Mass times g, 9.81, times what here? Not distance. Instead of d, we will write height, h, because it is height. So if you see a change in height, direct, what has to come to your mind? Force of gravity, because gravity is doing work, so we have work of gravity. Okay, now if the object is moving horizontally, I'm pushing the shopping cart, in this case, no work done by gravity. Okay, work done by gravity if the object is moving up and down. The work of gravity depends on change in height. The work of gravity for horizontal motion is zero. We said that because while you are moving horizontally, displacement and force of gravity, they are perpendicular always. When the force and displacement are perpendicular, work equals zero. When an object follows any path consisting of a combination of vertical and horizontal motion, the work of gravity depends only on the vertical change in height. Sometimes you will say, teacher, okay, not all objects moving vertically or horizontally. Sometimes objects, they are moving with angles. Okay? So in this case, diagonal. In this case, we will take only, we will resolve the displacement, and we will take only the displacement, the vertical displacement only, the one that is on the y-axis. Okay, after we resolve the displacement. Gravitational potential energy. Remember gravitational potential energy? Here is it, the formula mass times g times height. Okay, look at this formula for work of gravity. Mass times g times the change in height. The same or no? Yes, it's the same. So what do you understand? That gravitational potential energy and the work done by gravity appear to be nearly identical to each other. The difference is that the potential energy of gravity is an instantaneous energy at a specific height. Now work is what? Now when we measure work, we measure it for this displacement from here towards here. But when we measure gravitational potential energy, we measure it for one point. For example, we measure it at this point here for this object. So we say mass times g times the height. We don't care about the change of height. Okay? This is the difference between work of gravity and gravitational potential energy. Let's see this example together. In the figure above, mass m is positioned at the top of a frictionless incline with an angle. The mass slides down the incline a distance delta d. Determine the work done by gravity. Okay, look now, here is an example for an object moving not vertically, not horizontally. At the same time, the object is moving vertically and horizontally with an angle. Now we know that here it's not horizontal, it's not vertical, but here what I have? I have the height of the object. So the object is here. Then the object will become here. So we have a change in height. We have a change in height. We are going to take for the force of gravity delta H. I don't care about delta D. I don't care about delta D. I will only take delta H because we said force of gravity is related to the change in height. So two displacements are occurring, delta H and delta D. Use the change in height since it's parallel to the force of gravity. So we write the formula work equals force of gravity times delta D parallel. So work equals force of gravity times delta H. Work of gravity equals, now what is F, force of gravity? Mass times G times the change in height. Okay, so in the exam I bring this question with numbers and I give you delta D and I give you delta H. You are going only to use this one to find the work done by gravity. Okay, the last thing, the sign of the work in this case is positive. Why? Who can tell me why? Force of gravity is toward down. The object is sliding toward down. So both of them at the same direction. So force of gravity, work done by gravity is positive. If the mass starts to move from here toward up, and I ask you to find the force of gravity in this case, the force of gravity, the same formula we are going to use. The only difference is that work is negative in this case because the object is moving toward up and the force of gravity is toward down, opposite to each other, so negative work.